Okay, so we are starting the last chapter that we are covering in the class. So it's chapter 9. It's on counting and probability. Of course, it has other sections too on sequences and series, but we are not going to discuss those in this class. So we are going to concentrate on counting and probability. So in this first video, I would like to talk about counting principles. And when you're counting, for example, large quantities of objects or people, then you have to be, you can count every single one of them, but then, or you can do, for example, if you're in a big auditorium and you want to count the number of people, you might just, instead of counting every single person, you can just count the first row, how many people sit in there, and then multiply by the number of rows and so forth. Or as they say in the baseball stadium here. But let's talk about more specific ways of counting. For example, if you have this spinner here, we want to know what are the possible outcomes. How many different possible outcomes do we have? One way of counting would be what we call the tree diagram. So you can see how it is organized, look like the branches of a tree. You see, if you spin this once, obviously you might get an A, you might get a B, or you might get a C. So A, B, C. If you spin it again, and if your experiment is spinning this spinner twice, so that would be the first time that you spin. The second time, if you had an A, the second time around, you have a choice of A, B, or C. For B, if you had a B the first time, your second time again, you have three choices, A, B, C, and same thing with C. So then how many possibilities would you have if you spin this twice? You just count the end of the branches, 3, 3, and 3. So that's 9 different possibilities. So that's one way of counting. If you look at example number 1 on the next page, it says a basketball player is fouled and awarded 3 free throws. Let H represent the possibility of a hit, basket is made, and M the possibility of a miss. Determine the possible outcomes for 3 shots using the tree diagram. So you're doing 3 shots. So the first shot, basketball player can either miss it or hit it, make the basket or miss it. Second time, hit or miss, hit or miss. Third time, hit or miss, hit or miss, hit or miss, and so forth. So you just count the end of the branches. So how many possibilities can you have? 1, 2, 3, 4, 5, 6, 7, 8. 8 different possibilities. Okay? All right. Now, this paragraph here, this little paragraph here is important because the terminology that is mentioned. It says, to assist our discussion, an experiment is any task that can be done repeatedly and has a well-defined set of possible outcomes. So shooting the basketball and hitting or missing it, that's an experiment and has defined possibilities, results. Excuse me. Or spinning the spinner in the last page, that has defined possibilities, and we can do it over and over and over again. All right. Each repetition of the experiment is called a trial. So if you're talking about the spinner in the last page, if you spin it once, that's 1 trial. If you spin it twice, that's 2 trials. A sample outcome is any single outcome of a trial, while the sample space is the set of all possible outcomes. Okay, so if you just look at this, that's a sample outcome. Or rather, if you look at this, for example, that's a sample outcome. But if you look at all of them, that's called a sample space. That contains all the possibilities. Okay. All right. So let's look at example number 3 on this page. And I'm gonna cover the answers here because I already wrote on it. Don't tell anybody. It says a digital security system requires that you enter a 4-digit PIN number using only the digits 1 through 9. Now, I'm sure everybody knows that when we talk about digits, we are talking about numbers from 0 to 9. And that those are 10 digits from 0 to 9. So we have 10 digits. So anytime we're talking about digits, it's from 0 to 9. Now, number 10 is not a digit because it's made up of 1 and 0. So those are the digits. Or 11 is not considered a digit because it's made up of 1 and 1. So here in this problem, you want to see how many PIN numbers can you make by just using the digits 1 through 9. So you're not using 0. How many codes are possible if you do this? Repetition of digits is allowed. So if the repetition, and you have 4-digit PIN, right? So if the repetition is allowed for the first number, how many choices do we have? Well, I can pick 1, 2, 3, 4, 5, 6, 7, 8, 9. I can pick any of those digits from 1 through 9. So I have 9 choices. Okay, let's say I pick 9 or 8, whatever. Can I pick it again? Yes, because according to the directions for part A, you have a repetition is allowed. So can I pick 8 again? If I picked 8 here, yes. So I still have 9 choices. Can I pick it again? Yes, I still have 9 choices. Can I pick it again? Yes, I still have 9 choices. So if the repetition is allowed, then the number of PIN numbers that I can form is 9 times 9 times 9 times 9, or basically 9 to the power of 4, which is, 9 to the power of 4, it's 6,561. So if repetition of digits is allowed and you have a 4-digit PIN number, you can have 6,561 different types of PIN numbers. So that makes it very difficult for anybody to hack into the system or somehow try to find the PIN number. Okay, let's look at part B. Part B says repetition is not allowed. So you still have 4 positions to fill in, right? Let's say I pick 8 for the first digit. How many choices do I have? I have 9 choices. I can, I'm sorry, let me take that back. I have 9 choices to choose from, right? From 1 through 9. I can pick any number I want. So I have 9 choices. So let's say I pick 8 for the first number. Can I pick it again? No, I can't, because it says part B, repetition is not allowed. So therefore, I'm only restricted to 8 choices for the second position, because the number I chose here, whatever it was, 8, I can't choose it again. So 8 is out of the game. So there's only 8 digits left. Let's say I pick 7 here, number 7. Can I pick it again? No, 7 is out of the game. So now there's only 7 choices left. Let's say I pick 1 here. Can I pick it again? No, 1 is out. So I only have 6 choices left. So if the repetition is not allowed, the number of PIN numbers will decrease. So I have 9 times 8 times 7 times 6. So I will have 3,024 different possibilities for the PIN numbers that I can form if repetition is not allowed. Okay, and let's see, part C. The first digit must be even. Okay, so the first digit must be even. So from 1 to 9, how many even numbers do we have? We have 2, we have 4, we have 6, and we have 8. So the first digit have to be an even number, so we only have 4 choices. So for the first position, I only have 4 choices because it says the first digit must be even. And repetitions are not allowed. Okay, I'm looking at my answer. Okay, so whatever I pick here, I cannot pick here, I cannot put it over here because repetition is not allowed. So let's say I pick 2 for the first position. Can I pick it again? No, repetition are not allowed. So how many choices I have left here? 8. Let's say I pick 1 here. Can I pick it again? No. Can I pick whatever number here? No. So there is your answer. Well, we have to multiply. So 4 times 8 times 7 times 6. So you only get 1,344 different choices for this arrangement, when the first number has to be an even, first digit, and then you cannot have repetition. Okay, so that's example number 3. Now, you might encounter different types of problems. One type of problem that you might encounter that is related kind of to this is a problem about license plates. Okay, so let's say, I'm just making up this example. Let's say I want to make a license plate that has 6 characters. And the first 2 characters, so you have to be digits, so 2 digits and 4 letters. So your license plate has to be formed by 2 digits and 4 letters. Okay, so part A, repetition is allowed. So how many digits do I have that I can choose for the first position? I have 10 choices, right? Because I have 10 digits from 0 to 9. So I have any of those 10 digits can be used for the first position. Repetition is allowed. So whatever number I pick for the first position, let's say I pick 3. Can I pick it again? Yes. So I still have 10 choices for the second position. All right, I'm done with the digits because it only has to have 2 digits, now 4 letters. Now, we are talking about here the English alphabet. English alphabet has 26 letters in it. So for the first position, what are my choices? I can pick any of those letters in the English alphabet. So I have 26 choices. I can pick K, I can pick M, I can pick Z, whatever. I have 26 choices. Repetition is allowed. For the next position, I still can pick 26, any of those 26. So I have 26 choices. 26 choices, 26 choices. So 2 digits, 4 letters. And you multiply all of these. So that's 10 times 10, 100. 100 times 26 to the power of 4. So that's big. So you can have that many choices. 45,695,600 different license plates. Much more than the population of the state of California. Hopefully we don't have that many cars. Okay, but what if repetition was not allowed? No repetition. So I still have 10 choices for the first digit, but I cannot choose that again. Whatever number I chose here, let's say I picked 5, I can't choose it again, so I only have 9 choices. For the first letter, I still have 26 choices. Let's say I pick K. Can I pick it again? No. So I have 25 choices. Now for this, let's say I picked W. Can I pick it again? No. So I only have 24 choices and 23 choices. And you multiply all of those, obviously you will have less number of choices. So 10 times 9 times 26 times 25 times 24 times 23. that gives you 32,292,000 different license plates possible. Okay? All right, I'm going to stop right here. We'll pick it up in the next video.